I work as a cloud advocate at Microsoft. You can find me on Twitter at Chris_Noring. My IMs are open. I'm happy to answer any questions you might have about this or anything else. Svelte. Svelte is the topic for this 20-minute presentation. I can't teach you all of Svelte in 20 minutes, but I can give you the main points, the key points where I think you should be interested. So I hope you're with me for this somewhat intense presentation. One of the first things we need to ask ourselves is why? Why another SPA framework? Why Svelte? Well, one of the big things about Svelte is the fact that you don't need all that boilerplate. You don't need to remember that much syntax to be productive in Svelte. And this really speaks to me, because if something is able to remove the cognitive load of having to remember JSX or maybe some structural command or whatever it is, I'm going to take it, because there's so many things I need to keep track on already. If a SPA framework can help me with that, why not? It's fast. It doesn't have a virtual DOM. Whether that is bad or good, can be discussed, but it is fast. It also doesn't have a script tag. So Svelte bundles standalone components without including a framework script as a dependency. So what that means is that Svelte will compile, and it will compile your code into a state where it's all vanilla JavaScript. So you will never see that reference towards a Svelte script tag. Now, that might be the case with a lot of the modern SPAs nowadays, but just for information. Svelte can swap out individual components or replace your entire application. So how much Svelte you want in your application is really up to you. It works with the standard rather than trying to invent its own. So in that case, or the argument here is that you mostly need to learn HTML, CSS, and JavaScript. You don't actually need to learn that much Svelte, and I will show you exactly how. There is one component per file. This is somewhat of a standard nowadays for SPA frameworks, or at least a few of them have adopted this model. I know Vue does. In Angular, you can definitely do so. It's recommended. In React, you can have more than one component in a file, but usually it's a good idea to just keep one component per file. Styles are scoped by default. This is really nice. This means that we are avoiding collision with CSS names. We all know how painful that can be and how many hours we can waste on trying to debug CSS. It is just HTML, CSS, and JavaScript. I keep on saying that, but I will show you. But you also have all of these features that you're used to. So everything that you're used to inside of a SPA framework, such as input properties, the ability to watch changes, the ability to raise different events, you have that. So you don't need to feel like, hey, I'm going to start using this SPA framework and it has no features. It has none of the features that I'm used to, that I love from Angular or Vue or React or whatever SPA framework that you currently love. It's invisible. Now, I keep saying that, but here's the proof. So if you look at this black box here on the left, what you see is what you will write. You have a script tag, you got something in that script tag, a variable, and then you spend some time interpolating that into a header. Now, this could easily just be HTML with a little help of some kind of handlebars, for example, right? And you would replace this name occurrence with with the string world, and you would end up with hello world. What Svelte ends up creating is all of this here to the right. You don't have to create any of that. That's what ends up in your build folder. And that's where it should stay, because you shouldn't have to deal with this. You shouldn't have to remember any of it. And that's the message that Svelte is here to give you. So how do I get started with Svelte? Well, there are a few different ways. There is svelte.dev. It's an excellent interactive tutorial. There's no setup. You just go in there, and I think there's something like 15 or 20 different demos that teaches you various features of Svelte. I can't recommend that highly enough. Svelte.dev. Right, so the other way is that you think that you can create this project by yourself. Definitely you can do that. And what I did when I learned Svelte was to go into svelte.dev. At the same time, I was scaffolding a project and I was trying to replicate the same features that I saw on svelte.dev, and I was trying to do the same in my project. So what I have to do is to run an npx command calling the git, and I'm telling it, give me the Svelte template, and I give it a name. In this case, I'm giving my project the name Hello App, but you can name it whatever you want. And then I run npm install and npm run dev. And that's it. But I actually want to show you how fast this is, because you're not going to believe me unless you see that. So let's head over to our terminal and see how fast this really is. Okay, so we're inside of a terminal. We have more than one Svelte project. And the scaffolding command looks like this, if you remember from the PowerPoint slides. npx the git, we select the template, and we're going to call this one my demo. Here I am inside of my demo. I'm ready to do an install, npm run dev to run the application as instructed. So I install a few libraries here. Boom, bada bing, bam. Up and running on a new port, so we need to remember that port. And there we have it, folks. Hello world in Svelte. And as you saw, I just scaffolded the project, it downloaded a few dependencies, and bam, I was up and running. That was fast, right? Wasn't that fast? You were able to have a Svelte app up and running in no time. 2 seconds to scaffold, 2 seconds to start. I delivered, right? Okay, let's try to repeat what or how Svelte deals with data and how you can display the data. You use this interpolation syntax, you use the curly brace. We can see that as we have this source variable, and we're able to bind to that value inside of an image tag, for example, on the attribute, or we can bind inside of a div tag in its inner HTML. That works as well. And then we have binding where we want to change the data. In this first example, we see that we have an input tag. In the input tag, we care about entering data. And for this to work properly, we need the bind : value syntax. And then we have another type of input in which we have a number, and we can bind to the value once more. And lastly here, we have a different type of input altogether, which is a checkbox. And this one expects things to be yes or no. So here we can bind to this yes variable, which is a boolean, and if it's checked, it's false. If it's if it's checked, it's true. If it's not checked, it's false. So that's how you can change values. Events are handled by us having first a function in our component. In this case, we call it handled click, and we have this on : click, and we just assign it the name of the method. That's how hard it gets. We can also render HTML. Fair word of warning though, rendering HTML means you trust whatever you're trying to render, so make sure that this is trusted content before you attempt this. And what you use to render it is this @HTML directive that's able to interpret this as the HTML that it is. Components. It's all about components nowadays. Modern SPA frameworks are components, and the reason we have components is that we want our application to be simple to modify and simple to understand. So we have a ton of different components. One component does one thing well, and that's how we want to have things. A typical component looks like this. It has 3 different sections. The first section is a style in which we input our styles. And remember that these styles are scoped, which means that there will be no naming conflict with other component styles, because it adds this prefix to ensure it's unique. And then we have a script section. This is where our JavaScript goes. We define our variables, our methods, and what else we need. Lastly, we have our markup section. It doesn't have a template tag that you might expect from Vue, for example, but it's HTML right in the mix. And as you can see, we are using the source variable and interpolate that. We are also using the description variable, and both of those are referenced in the script section. We can import a component by typing the import keyword, give it a name, and then in the from instruction, we just tell it where the component is located, and we are ready to use it as we do here at the bottom where we type nested. Looks simple, right? So import and use by just putting it here in the markup section. Now, with components, there are two major topics that we need to cover. One is input and the other one is output. Now, input is about data. Data flows from top to bottom, which means that data originates in a parent and it's being pushed down to a lot of child components that are each dedicated to rendering that piece of data in a very good way. Now, events are about something happening. Usually an event is something business importance, like hitting a save button, for example, and you need to tell a parent component somewhere that, hey, your child here said that someone pushed a save button, which means an update has happened, for example, and we need to communicate that upwards from a child to a parent to say, hey, this has happened. Component input is made possible through the export keyword. We start off here on the left with a let answer. We have the answer variable, and by adding the export keyword, we make it publicly available. If we don't have the export, everything is private. So we are exposing the answer variable here by adding the export keyword, and on the right we can see here at the bottom that we are setting the answer attribute with the value 42, and the 42, if we go back to the left side, it ends up being rendered inside of this child component called nested.svelte. We can also pass things by using the spread syntax. The spread has this ... syntax about it, and the main reason for using it is that because you don't want this behavior on the left where you have a person component here at the bottom where you set every single attribute from this object, but you'd rather either pass the entire object like you do with a ... syntax, or you might have a dedicated, let's say, data property and just pass on the object. So there's different MOs, different methods of operations to passing more complex data. Let's show this in a demo. So we'll work on the scaffolded project, we'll create a component, and we will add a click handler so you can see yourself that this is not that complicated. Okay, so this is our scaffolded project. I'm gonna stop that. And we have a very bare-boned project. So we have this main.js, which is the origin point for our Svelte project. And we also have the app Svelte, which is the first component. What we want to do is to create a simple component. In this case, we've created a product detail.svelte. It has a script section with some JavaScript in it, and it interpolates the title. Now, we don't expose this title property at all. We will do that as one thing. And if we look here at app Svelte, we do no attempts to set any properties because there are none or there are no properties exposed. To fix this, we can first make it public by adding the export keyword, and we can also add the on click here and call a handled click. So we're doing two different things. We need this function, we need a handled click there, and we're just gonna have a simple alert at this point. There. We've done two things. Make it public, so we from the outside can set this value. Here we go. And we can make sure that we have a let product, well, send across a movie. So we do so, and send it downwards there. Okay, so we have set this title, we have made it public, and we also have a handler. All good. And we can see that movie is being interpolated, and when we clicked movie, we also got this alert window, which means both the public property and the click handler is working fine. Amazing. Let's talk about component output. What we need to remember when it comes to the output is that we do this in steps. So first off, we create a dispatcher using this helper method, create event dispatcher. Then we dispatch the event, we raise the event by giving it a name and an optional payload. And lastly, we try to capture this event in a parent component, or the parent component just leaves that to its parent, which is called forwarding. Now, here's a component where we work on the output. The first thing that happens inside of this component is that we import the helper, create event dispatcher. Next up, we create the dispatcher object. And inside of this function here called handle event, we call dispatch. We give it a custom name. In this case, we call it message. And the second parameter is an object in which we specify some kind of payload. That was the custom name of the event. And looking at it from the consuming component, we can see that this custom name, this message that we invented, needs to be reflected inside of the markup. So we have that on :message, and we assign the handle message to it as the one that responds. And we can see also in the handle message of the app.svelte that we need to dig into this event and go into event.detail.text to find our payload data that we send across. Forwarding is about the immediate parent not answering but saying, hey, I'm good, I'm going to leave this over to my parent. So we do first a dispatch from the child that say, here's a message, here's a payload. And the parents say, oh, okay, I hear you about the event. I don't immediately care, but I'm going to send this off. So there's no handling function in this parent, but just the statement of on : message. At which point we reach the parent's parent that says, I actually care. And on my on : message, I have a handle event and I am able to display the payload from the raised event. Reactivity is an interesting topic. Essentially, it's about computed variables and being able to listen to when a computed variable changes and run a piece of code. So here we have the $: and we create this doubled computed variable that comes from as a result of the count variable times 2. So every time the count changes, the double will change with it. And we have the ability to listen to when that happens. So in this case, we have the $: and we can simply execute this console log statement and say, hey, you changed. So therefore, I print this to the console. We also have a multi-line version in which we just add a curly brace, and we're able to run a console log and an alert and whatever else kind of functionality that we're interested in running when something changes. Right, let's talk about directive as the last thing in this presentation. There are powerful statements. They happen inside of your template. The 3 I wanted to cover is if-else, conditional parts in your template, each, which is the for loop, when you have lists, for example, on your object or list that you want to render. And lastly, the await structure that enables you to render out promises. Now, the if-else logic looks like this. It's a handlebar syntax. If with a boolean, render this. If it's false instead, then render that portion of the template. And this is just a closer if. We can make that more complicated with else if. So you can see that we're adding else if and as many else if statements as we need. And, except for that, it's the same kind of structure like the if and else. We also have for loops, in which case we use the each keyword, and we have a list. We have an item, so we give each item a name, and we're able to also spread it. If we're interested in specific things on this to-do item, then we're able to spread out so it's easy for us to print specific properties like name, ID, or done. And for performance reasons, we might want to pick out what's the unique property so it renders better. This is how you would do that. The await block is interesting because if you look at the top here, you see that we have a promise variable that is the result of us calling getData. GetData is a method that first fetches data, turns that into JSON. If you look at the template, we see that we have an await syntax that waits for the promise to be successful. So meanwhile, while it's waiting to resolve, it's typing ... loading, which makes sense. You might want to have a spinner here. And on the then keyword, we render successful data. And on catch, this is where the promise is being rejected. So this is a very nice syntax sugar. Routing is not something that's officially supported by Svelte, but there are many good different options. This is one of them, and it makes it fairly straightforward for you to set up different routes and different links, so you have a multi-page application. As for testing happens on the surface rather than unit testing. So here's all the instructions you need to get started with that. And as a simple demo of what this does, you can see that it's able to look at the surface and see if a component renders a specific text. And you can also have tests where you grab a reference to a button and invokes a click event, and you can see whether your component has changed in the way that you think it will. So that's a different paradigm, but if you've done React before, you will recognize this type of surface testing. In summary, this was a lot to cover in 20 minutes, but hopefully it got you interested to see that Svelte is a real contender out there and a real option. It's been around since 2016, and now version 3 is very easy on the eyes. It's the new kid on the block. It's another SPA framework, and we all love those because we like to change those every 6 months, am I right? It's easy to learn. Most of what you saw today was HTML, CSS, and JavaScript. It's a compiler, so you don't see any framework at, after compile time. It has a small footprint, no VDOM. It has tooling for Vim and VS Code, and it's dependent on some OSS libs. Not everything is included. You will need to add a router. You will need to add a test lib. Thank you so much for listening, and I hope to see all of you next year in Warsaw.